max 2 pi f. So Im is nothing but the maximum or peak value. So this is nothing but the maximum or peak value. Omega is nothing but this. It is expressed in radians. T is nothing but the instant of time. So that means at this instant of time t. So that's what is at the instant of time t. So this instant is what is this time t. And the same this one. So when you want to find the value of sine wave at any instant of time t, you are going to use this representation. For voltage, it is similar. V of t is equals to Vm sine omega t. So that's what is the relations. So please remember this. Omega is nothing but 2 pi f. T is nothing but the instant of time f. So when you see this omega t, omega is nothing but 2 pi into f. F is nothing but the frequency. So this we have seen in the last class. So there is a problem, first problem. So please write the problem. So the problem says an alternating current I is given by the alternating current I is given by I is equals to 1.41 sine 314t. Find the maximum value, frequency, time period, and the instantaneous value when t is equals to 3 milliseconds. Okay, so everybody has written the problem, right? So what is the given data? So what is the data given? So the equation of sine wave is given I is equals to 141.4 sine 314t. So now when you compare this equation with the equation of sine wave, I is equals to Im sine omega t. So what is the maximum value of current? What is the maximum value of current? That is the first one. So when you compare these two, what is the maximum value of current? Anyone? Because when you are comparing with this, this becomes the Im. Im is nothing but the maximum value. Okay. Second one, we need to find the frequency. So what is the formula you have to find the frequency in equation of sine wave, which is omega. Omega is nothing but 2 pi f. So from here you can find the frequency. So now what is the value of omega? So when you compare these two, is 314. So frequency is equals to 314 divided by 2 pi. So how much you will get for this? 14 divided by 2 into 3.1. 50 hertz. So third one is time period. So how will you find time period? Formula to find time period, T is equals to 1 by F. So 1 by 50 hertz, 0.002 or 20 milliseconds. Okay. Clear? Up to here everything is clear? Everybody is writing? Right. So next is the fourth. You want to find the value of the current at time t is equals to 3 milliseconds. Milli means 10 raised to the power of minus 3. So what you are going to do, you are going to substitute I 3 milli is equals to 141.4 multiplied by sine 314 into this t. This t you are going to substitute 3 milliseconds. Now what will be the answer here? So Calcis, can you tell me the answer by substituting the values? Anyone? Anyone calculated? This is what you are getting. So only thing you have to do if you get this answer, that means your calci is in degrees. So you have to change your mode of your calci to radians. Then you will get the correct answer here. So this is the what I was saying with the problems. So whenever you are going to use this fourth point, the instantaneous value when t is 3 milliseconds, so you have to change your calculator mode into radians because this omega is in radians. So you cannot use your calculator in degrees. So you cannot use your calculator in degrees. You will get the wrong answer. Okay. So change the calculator mode into radians, and you have to find the value of current. Okay. So almost minute. There are almost 41 are there. Still nobody is using calci. Get the answer till now. So you do it and tell me what is the answer here when it is in radians. Okay. So we'll go to the next problem. So this is the next problem which is there with respect to the similar kind of what we have done previous. So the maximum value 14.4 amperes. Then angular frequency omega, which is nothing but 377. These are the data which you get from this instantaneous representation of the sine wave. So first one is to find the RMS value, RMS. So what is the formula to find the RMS? 0.707 multiplied by the maximum value. So that is 0.707 multiplied by 14.14. So that is your maximum value. So it is 9.99. So which is approximate equals to 10 amperes. Okay. So your RMS value is 10 amperes. Second one is frequency. So same again, F is equals to omega by 2 pi, because omega is equals to 2 pi f. So now 377 divided by 2 into 3.14. So how much is this? How much is the value? So third one, you need to find the value of current at again at 3 t is equals to 3 milliseconds. So I of 3 milliseconds is equals to 14.14 sine 377 multiplied by 3 into 10 raised to the power minus 3. So you need to tell this answer. Your calcium mode should be in radians, not in degrees. Next, fourth one, you have to find the time taken by the current to reach 10 amperes. Okay. So fourth point, you need to see from the same equation, Now current is given as 10. 10 is equals to 14.14 sine 377 t. So you need to find this time t. So from this equation, you have to find t. So these two answers you have to uh, put a message. Okay. Be fast. Take the calci, substitute, and put the message in the chat box. So what is the third answer? That is 14.4 sine omega t. So this one, when you substitute, what is the answer? Change your calci mode to radians. 12.794 amperes. Similarly, here, so when you do it, sine 377 t is equals to 10 divided by 1.4. Sine inverse of 10 divided by 1.4 divided by 377 will be the time. So just going whereas here. So sine 377t is equals to 10 divided by 14.14. So when you move this sine this side, So 377t will be sine inverse 10 divided by 14.14. So once you find this, t is equals to t is equals to entire divided by 377. So this value should come here. So that you can find, right? So that simple substitution